So today we're going to be looking at properties of radicals, and we'll just be doing the first part of this because this will be a 2-day lesson. So let's just go ahead and remind ourselves, what is a radical expression? Well, it's an expression that contains a radical sign, or a radical. So something that we're probably most used to seeing is the square root. So something like the square root of 6. Remember, the number inside is what we call the radicand. And the sign is the radical. And we don't have to have a square root. We could have a third root. We can have a fourth root. So for example, if this was a little 3 here, then we call that little number the index. And that means we're looking for, 3 numbers that multiply to 6 that are exactly the same. So you don't also just have to have a single radical. Your radical expression could also be something like 3 plus the square root of 7, right? And just remember, the square root is the special one where the index is invisible. The index is this invisible 2. Okay? So every radical has an index. Now what we call the simplest form of a radical basically means you have a radical expression that meets these 3 conditions. Okay, and we'll look at this in the example. It might make more sense, but the first condition is no radicands have perfect nth powers as factors other than 1. Meaning we can't simplify the radical any further. Okay, no radicands contain fractions. So remember, that's the number inside the radical, no fractions. And then no radicals appear in the denominator of a fraction. So you're not going to see that little house, that little radical sign in the denominator. Okay? So, thinking about all that, because we want to make sure we simplify as much as we can, let's remember how to simplify some radical expressions. So, what I like to do with these, especially when my numbers are really big, is I like to do a factor tree. So for example, something like 147, I might not know off the top of my head it's, 49 times 2 or something like that. So I like to break it down completely. So when I see 14 and 7, I'll think, oh wait, I can divide that by 7. So let's take out 7 and I get 21. And then here I get another 7 and 3. I'm going to look at the bottoms of the tree, so those prime factors, and use that to rewrite this radical. So that's 3 times 7 times 7. Then what you want to look at is you want to look at the index. So remember that square root has the invisible 2. So that tells me I'm looking for groups of 2 of a kind. So see how I have a 7 and a 7 there? That means this is basically the square root of 7 squared times the square root of 3. I like to take my group out front and then the leftovers in the back because that's how I'm going to write my answer. Anything that doesn't get circled, you just put it in one radical at the end. And then we know the square root of 7 squared, the radical and the exponent cancel out because the index is 2, right? So the little 2's cancel out. So I get 7 square root 3 as my simplified answer. Okay? B, same deal with your variables as well. What you can do is you can basically rewrite this. Now hopefully we all know that 25 is 5 times 5, but if not, do your factor tree. And I'm going to list out all the letters as well. So this is 5 times 5, and then 1, 2, 3, 4, 5 x's. And remember again, this happens to be a square root, so that's a little 2 there. So I'm going to circle all my groups of 2. And this ends up becoming the square root of 5 squared. So each group I'm going to make its own square root for, then x squared, then an x squared, and that one little lonely x will be all by itself at the end. And then remember, this exponent cancels out the root, or the radical sign, so I end up taking out a 5, x, and square root of x, and let's simplify that to 5x squared square root x. Okay, so that's how we can simplify our square roots. Go ahead and try 1, 2, 3, and let's come back and check your answers. All right, go ahead and check. Hopefully number 2 didn't trick you. Remember that negative sign is basically a -1. So do that square root of 80 and then at the end multiply it by -1. Make sure you come back and ask me questions if you want to see any of these. I'll be happy to show you in class. Okay? So we're going to look at another property, and then we're going to also look at simplifying cubed roots. So if we take a look at the back, we've got our quotient property of square roots. So this quotient property of square roots is actually pretty simple. You'll see if we have a square root of a fraction, all you do is basically split off that square root onto the top and to the bottom. That way we can simplify that. And then the tricky thing here is make sure we don't have any square roots in the denominator at the end. That's what we have to be careful of. Okay? And then we're going to look at these cubic roots. And the only difference here is now we have an index of 3, so we're looking for groups of 3. So let's go ahead and do a few of these examples, and then you guys can try some on your own. So with C, using the quotient property of my square roots, I'll remember that I can basically give that radical sign to the top and to the bottom, and then see what I can actually simplify. Well, we don't know what the square root of 11 is, so I'm going to leave that alone, but I do know the square root of 36 is 6, and that's good because I don't have a radical sign on the bottom, and no more fractions inside that symbol as well, right? D, same deal, right? I can split up that square root, so it's square root of 144 over the square root of n squared, and this is great because I know the square root of 144 is 12, and the square root of n squared, remember that's a little 2 here, so it cancels out the 2 inside, and we're left with an n. Okay? How do we deal with the cubic root? Well, remember how with the 2 we're looking for 2 of a kind? 3, we're looking for 3 of a kind. So I don't really know the factors of 135, so I'm going to do my factor tree. I know it ends in a 5, so I can take out a 5, so this will be 5 and 27. 27 I know is 3 and 9 is 3 and 3. So I'm going to rewrite this as the third root, or the cubic root, of 1, 2, 3 3s, and a 5. And remember, I'm looking for 3 of a kind, so I want to circle a group of 3 of a kind. And then I'm going to rewrite my radical. So I want to make sure I bring the index down with it, so that's the cube root of 3 to the third times the cube root of 5. And just like before, notice how the little 3's cancel out, so I can take away that radical sign, and I get 3 times the cubic root of 5. Simple, so we're just looking for groups. Okay? I'm going to skip F, and let's look at H. So how do we deal with something like this with this larger fraction? Same thing as before, right? It's a cubic root, but we know we can basically break up that radical sign, give it to the top, give it to the bottom, and then simplify those separately. So what's great about the bottom, I already see the 3's cancel out for the B there. And then if I'm thinking about 343, I might be, oh gosh, what can I do with 343? Well, with a little guess and check and some multiplication, I'm going to do my factor tree, and notice this is 7 times 49, and 49 is 7 and 7, right? And then I have 8 A's, so I have 1, 2, 3 7's, and 1, 2, 3, 4, 5, 6, 7, 8 A's. And I'm still looking for groups of 3. So I have a group of 3, group of 3, a group of 3. So I'm going to rewrite this as the cubed root of 7 times, let me move my paper over, the cubed root of a to the third times the cubed root of a to the third times the cubed root of a squared, all over b. Okay? And then I can simplify that because, oops, that's 7 to the third. That didn't get written there. So now I can simplify this because these radicals and the 3's cancel out, right? And the last one doesn't. So I'm left with 7a squared times the cube root of a squared all over b. All right? So we're looking for groups. That's the basic gist of the story. Go ahead and try 4, 5, 6, 7. Ooh, and that should say 8. And then we'll come back and check your answers. All right, couple of notes. Make sure you solve for number 7, this negative 27. We're looking for 3 numbers that were the same. So it's negative 3 times negative 3 times negative 3. So we have a negative 3 as our cube root of negative 27. And 8 might have been a bit tough because there's a lot going on there. But if you wanted me to show you how to do it, definitely ask in class because we want to be able to do these larger problems. All right, thank you for listening.